Okay. Now, a couple of corrections, not really a correction, but I said the typical volume increment is, I said, I'm going to be more specific and say the typical volume increment has volume, right? And I use dx and dy and dz because that's how I often type things with a backward apostrophe and stuff. But it's a delta x, a delta y, and a delta z. It's not an infinitesimal quantity. It's a finite quantity. It's going to approach zero as limits and end up being integrated in a manner I hope we understand with some depth. But anyhow, there it is. Now, what's the mass of the kji increment? Well, you got as far as its density times volume. You even wrote a rho times the dx, dy, dz, or delta x, delta y, delta z. But there were no subscripts. Okay? Rho changes all over the place. We got to evaluate rho at a point to find its value. So at what point are we going to evaluate it?
X star with all those
Yes.
subscripts.
I stopped you before you could say it wrong. You've been listening to me.
I wasn't even gonna say
It's the only
it.
reason. It's the only reason you might say it wrong. I think if you hadn't been listening to me, you'd be fine. Right? And then and we're not going to write all this out. We'll just write because we understand that this is delta x kji, which is the delta x that corresponds to this sample point, right? Okay. And if we look back here, there's your delta x, there's your x kji. Delta y, ji, delta zk. Okay? So all the stuff you're trying to write down is too vague. You got to be specific. Where is rho evaluated? Otherwise, you have no idea what rho means. Right?
Delta Z I.
I'm so used to delta z being a k, and I'm glad somebody's watching me. Okay. And I feel sorry for anybody who might be watching this and trying to keep everything straight. But the idea is, concepts are all right. Okay. Make sense? Okay, so what's a moment of inertia?